So chapter 2 is very different from all the other math chapters you've ever learned before because it's about conditional statements. So conditional statements are like if-then statements. You are going to write, and it's going to be a lot of writing for homework and almost minimal arithmetic for the next couple of sections, okay? Which is good or bad depending on you as a person. But that means that like when you go to do your big ideas homework, it's going to say either highlight something, you're going to highlight it, or it's going to say write this, and you're going to have to type it in. Thank you, Mars. And you're going to have to actually type it in, okay? So it's a weird thing, but it helps us to start to learn how to read theorems and postulates, which we're going to have a lot more in this book. So a conditional statement is one that has two parts, a hypothesis and a conclusion. It is usually written in if-then form, but not always. And it would be something like, if you study, then you will get an A. So the hypothesis would be the if part. So this is the hypothesis. The you study, in this case, would be the hypothesis. And then the you will get an A is the conclusion. Now, the actual hypothesis does not contain the word if. It's what follows the word if. And the conclusion does not contain the word then. It is what follows the word then. So on this slide, notice that the red, which is highlighted, is you study. And then the blue is the you will get an A, is the conclusion. So you will literally get a question on the homework that says, highlight the hypothesis and highlight the conclusion. And that's what you're looking for. It's not always first and second. It's what follows the word if and what follows the word then. The negation of a statement, think negative, right, or opposite, is the opposite of the original statement. So if my original statement is that it is raining, then the negation is it is not raining. If the original statement is the shirt is not red, then the negation is the shirt is red. So it's the opposite of wherever you started. The converse is formed by changing the order of the hypothesis and the conclusion. So we make the if the then and the then the if. It still has to make sense grammatically though. So if my original statement is if you study, then you'll get an A, then the converse is if you got an A, then you studied. The inverse is formed by negating both the hypothesis and the conclusion. So we state the opposite of the if and the opposite of the then. If our original statement is if you study, then you will get an A, then the inverse is if you didn't study, then you didn't get an A. So we're not saying these are always true or always false. They're just conditional. At some point it will ask you if it is always true or always false, okay? But for right now, we're just switching the order and changing the negation. The contrapositive is the combination of both the inverse and the converse. So we switch the order and we negate both parts. If you think about it, contrapositive in comparison with the other two is a longer word, so it's more of a process, okay? You switch it and negate it. You do both. So if my original statement is if you study, then you'll get an A. The converse, we would switch the order. If you got an A, then you studied. The contrapositive, we then negate that. If you didn't get an A, then you didn't study. A biconditional statement is made if the conditional statement and its converse is true. Then the statement can be written as a biconditional statement, which uses the words if and only if. Any definition can be written as a biconditional statement. For example, a right angle is an angle that has a measure of 90 degrees. So if it's a right angle, then it has 90 degrees. And if it's 90 degrees, then it has a right angle. Or then it is a right angle. Both of those would be true, which means we can say as an if and only if. We take the if out of the beginning and we put the if and only if in the middle. So if my original statement is if an angle has a measure of 90 degrees, then it's a right angle, then we can write it, and you can write it in two orders. An angle is a right angle if and only if its measure is 90 degrees. Or an angle has a measure of 90 degrees if and only if it is a right angle. You can only form a biconditional statement if the original statement and its converse are both true. So let's think about what happens if it was not that way, right? So I can say if your birthday is September 2nd, 2022, then your birthday is on a Friday. Okay. Is that true? Yes. If you were born today, then your date of birth, right? Or your birthday is a Friday. That's true. But what would be the converse to this?
Converse.
Yep. So switch the order. If, go ahead, Santi.
If your birthday's on a Friday,
Yep.
then your birthday's on September 2nd, 2022.
Is that true?
Not always.
No. Any Friday would have any date, right? That is on a Friday. So what if your birthday was next Friday, right? So your birthday would still be on a Friday, but it would no longer be September 2nd. Does that make sense? So the original one can be true, and the converse can be false. If this happens, we cannot make a biconditional statement. You can't say your birthday is September 2nd, 2022, if and only if your birthday is on a Friday. You can't say it if they're both not true, okay? They both have to be true. So a lot of times we do this with like a definition, okay? You could say like, if your birthday is September 2nd, 2022, or if your birthday, no, because even that wouldn't work. I'm trying to think of something else besides a definition that would work. I'll think of something. But most of them are definitions, okay? So if it works both forwards and backwards, okay? If it's 180 degrees, then it's a straight angle. If it's a straight angle, then it's 180 degrees. Now you can say, or if two angles form a straight angle, then their sum is 180 degrees. That even in itself, when you reverse it, could be any pair of supplemental angles that don't form a straight line. So you has to be true forwards and backwards. All right, so this is kind of all of it on one slide, okay? Except that we use symbols. So the P we use to stand for the hypothesis and the Q for the conclusion. In an original statement, my symbols would be P then Q, and that would be if and then. The converse, we switch it. So we just use this as shortcuts when we're referring to it instead of writing it all the way out. So if the original conditional statement is P then Q, the converse would be Q then P. The inverse would be this little squiggle, which is our not P and not Q. And the contrapositive is the combination of both, not Q, then not P. The biconditional, we use a double-sided arrow. Biconditional has the arrow going both ways. So instead of writing all those words out, we tend to shorthand it with these symbols. All right, example 1. Use red to identify the hypothesis and blue to identify the conclusion, then rewrite the conditional statement in if-then form. So this says all birds have feathers. What's the hypothesis? The birds, right? What's the conclusion? Have feathers. How do I rewrite that in a if-then form? Go ahead.
If an animal has feathers, it is a bird.
Okay, that, reverse it.
If an animal is a bird, then it has feathers.
Good. If an animal is a bird, then it has feathers. B, you are in Texas if you are in Houston. What's the hypothesis?
If you are in Texas.
Nope.
No, if you are in Houston.
Good. You are in Houston. So be careful with the order. It's always after if. You are in Houston, and then you are in Texas would be the hypothesis. So if you are in Houston, then you are in Texas. And this one might be a biconditional statement because I don't know if there's another Houston. But if you said something like, if you are in Gainesville, then you're in Florida, that could be false if it's reversed because there's like a Gainesville in Georgia, right? Or so like if there's a city somewhere else, then it doesn't, you can't do a biconditional. All right, this one says, let P be you are the guitar player and Q be you are a musician. Write each statement in words and then decide whether it's true or false. So what's my conditional statement?
If you're a guitar player, you're a musician.
Good. If you are a guitar player, then you are a musician. Is that true? Yes, true.
You would be,
B would be?
if you're a musician, then you play guitar.
Good. If you are a musician, then you play guitar. Is that true or false? False. C is the inverse. Which would be what? Good. If you are not a guitar player, then you are not a musician. Is that true? No. Just because you're not a guitar player doesn't mean you're not a musician, right? You could also be play another instrument. Or you could actually, if you're not a guitar player, then you're not a musician. Yeah. So. And D.
If you're not a musician, you're not a guitar player.
Good. Is that true or false? That one's true. So the way we typically determine if it's true or false is to figure out, is there a way for the if to happen and the then not to happen, right? So if you're not a musician, can you play guitar? No. And that's why that makes that true. Questions so far? All right, example 3 says, rewrite the definition of perpendicular lines as a single biconditional statement. So the definition says, if two lines intersect to form a right angle, then they are perpendicular lines. What's one way to rewrite it as a biconditional statement? Take off the if, right? Take off the if and say, two lines intersect to form a right angle, and replace the then with if and only if they are perpendicular lines. So two lines intersect to form right angles if and only if they are perpendicular lines, which is that little symbol is perpendicular. So we take off the if, we take off the then, and we insert the if and only if where the then is. And then obviously make sense of it grammatically. It would also be true the other way. So I could say two lines are perpendicular if and only if they intersect to form right angles. So that would also be true. Questions on that one? All right, last one. Rewrite the pair of conditionals as a biconditional statement. If M is between L and N, then LM plus MN equals LN. That's the first one. And the reverse of that, or the converse of that, if LM plus MN equals LN, then M is between L and N. How do I say this in biconditional?
M is between L and N
If and only if
M plus MN equals LN.
Perfect. M is between L and N if and only if LM plus MN equals LN. Or LM plus MN equals LN if and only if M is between L and N. All right, everybody make sure you see the assignment on big ideas. Oh, those of you that just joined, I wonder if it assigned to you.